Good afternoon, Bill Gustin here, captain with Miami-Dade Fire Department, along with Daryl Liggins, retired from Oakland, California, and Dennis Legear, retired from Oakland, California. Captain Mike D, Ladder Company 123, retired. Chief Ricky Riley, Prince George's County, formerly of Clearwater, but spent most of his career in Fairfax County. Ray McCormick, retired from 28 truck or 69 engine?
Ladder 28.
Okay, and then up in my upper left corner, we have, I can't see it because my screen is screwed up. Go ahead.
That's me, Brent Brooks from Toronto, Canada.
Brent Brooks. Okay, so Brent Brooks from Toronto. So the topic today is going to be vertical stretches and specialty nozzles, but it'll be, let me put it differently. It'll be specialty nozzles, then vertical stretches. There's no way we're going to be able to cover all the territory. Our special guests are Chief Ricky Riley and Dennis Legear and Ray McCormick, all good friends of mine, all fire screen kind of guys and lifelong consummate students of the fire service. I want to give a shout out to Key Hose. That's keys.com. I say it every session. Take the key challenge. Last week, we put a Bresnan distributor on a section, a 75-foot section of key 2-inch combat ready, and dangled it off the end of an aerial ladder. Now, the hose was S out in that, about a 3-foot space in between the beams of the aerial. So that's a tight squeeze, not a friggin' kink in sight, man. Just, we got our full flow, and we're building up to my department, and Brent is going to do a deep dive into this stuff. We've had some fires that have not had good outcomes, and they were involved in trench cut, let's just say that. And then we have had some fires where we have cut the lateral spread underneath the roof by inserting a Bresnan distributor, a 2.5-inch Bresnan distributor. So I know Brent is going to have a few things to say about that. I want to give a shout out to my buddies, Jacksonville, Florida. They take a 1.5-inch Bresnan, take the set screw out, and flip the rotating nozzle head upside down so that the pattern is from down to up rather than up and out. And they use that from down, which is, I think, is a brilliant idea for the interstitial space between a ceiling and floors supported by parallel cord floor trusses, which is the toothpick towers, arguably one of the nation's biggest problems, fire problems. We're going to show some pictures here, but I want to mention a good friend of mine, and we've been friends for 35 years, and that's Mike Reagan, who I invited to watch. Mike, I hope you're out there, bro. And Mike did me a real solid. 35 years ago, right now, Mike, myself, and a contingent from Miami-Dade Fire Rescue and Fairfax County Fire Department were the first urban search and rescue task forces ever requested by the Soviet Union. So we went behind the Iron Curtain and operated in Leninakhan, Armenia. So there is a very young, physically fit Bill Gustin with 2 Soviet soldiers. And Mike, again, God bless you for sending me these pictures. You can go to the next one. All right, this is a luxury first-class flying. We're flying in a C-141, a Vietnam-era cargo plane. And we took off from Andrews Air Force Base to Frankfurt, Germany, from Frankfurt, Germany into Leninakhan, Armenia. And it was quite the trip. And it was kind of cold. Frankly, though, I can tell you guys that with the cold, the smell isn't as bad, because I did the same thing in the Philippines, and I've had experiences here. So there's an advantage to the cold, maybe not to the person that's trapped, but for the rescuer, if you get my drift. There I am feeding my face. And the next one, okay, that's Mike Reagan, a very young, handsome, debonair Mike Reagan with one of the Soviet soldiers. Actually, every one of us got a Soviet hat. We traded ball cap for him. And I lost mine in Hurricane Andrew. But we had no idea how we were going to be treated. We were treated like kings, and no hostility whatsoever, nothing but gratitude. And I think we have one more, Mike. Oh, this is just explaining that the geology, if you will, behind the earthquake killed 50,000 people. And when I came back, it tried my faith. And I asked my dad, who's a very devout Catholic and a veteran of the Chicago Fire Department, why did God do that to these innocent people? And the guy, he's the best psychologist I could have. He said, God didn't do that. It's the crappy Soviet building code that did that. He had done his homework, and he was absolutely right. If there was any advantage of their chicken shit precast concrete with hardly any steel in it, it's that we could get through it with a claw hammer. So 50,000 people killed. And got one more. All right, there's the contingent from Miami-Dade, Fairfax County. The tall guy in the back is Mike Tamalo, passed away recently, but we formed a bond real quick, and it was the best of times and the worst of times. That's what I say. Mike, thank you so much, brother. So let's get into specialty nozzles. And Brent, are you going to do an examination of the Bresnan and how you apply it there in Toronto?
We do. And, we have several, we call them rotary distributors, just so we don't pigeonhole anything, but we do have the 1.5 inch. We have and a couple 2.5s, one that we use for standpipe operations, one with a cage that we can use for EV car fires, one that we can deploy off the top of a aerial ladder, and then one that we can use with our 4-inch coring tool. So we have different rotary distributors depending on the application. But at the end of the day, all of them we're using off a 2.5-inch hose line, and we call them specialty nozzles, but I call it smart water. We're using smart water now in these hidden voids because previous to this, we were putting water weight in the building and not being able to get water on the fire. And eventually we would either collapse something or we would destroy more property because we couldn't get water on the target. Now that we're using specialty nozzles, what I call smart water, or we're actually getting the fire extinguished with less damage and certainly putting less water weight in the building.
Now, Captain Mike, you guys have operated with the cockloft nozzle, which basically is a back-to-back bent tip. And can you use that nozzle both through a ceiling from below and from above through the roof?
Okay. Yes, you can, Bill. Yes, you can. Wherever you need it, But again, getting it through the roof requires a lot of people up on the roof to cut the holes and to get the line stretched up there. A lot of times it's easier and quicker to do it through an apartment up in there if you can get it there. But depending on the size of the building and everything else, getting a line up an aerial ladder to the roof stretched outside, up, getting the holes cut in the roof, and having all those people around with the running saws, it's a lot easier if you can. It's quicker, it's easier to stretch it, but it also depends on how many lines you have going up the stairs and everything else. So there are a lot of factors in this.
Yep. Chief Ricky, on the topic of fire streams and hose, Ricky Riley formerly from Fairfax. I have here my copy, highly highlighted of Fire Apparatus and Emergency Equipment magazine. And here is this article about 2-inch hand lines. You do you. And it's basically find out what works well for you. And this covers everything, not just nozzles, hose lines, everything. Tactics, techniques. Based on yours, not what the next guy's doing, not what FDNY is doing or Chicago. You find out what works best for you. And Chief Riley, I'm just going to quote you, plagiarize you, in your last sentence. So yes, the 2-inch line has a place in the fire service, and I am impressed with its flow and maneuverability, but it came with education and thinking outside the box to see how it fit in our department. I urge you to do the same. Now, Chief, you and I are good buddies, but you know what? You're never going to make it in today's modern fire service. You have way too much common sense. So that's got to do with everything. I'll get back to you. I asked you to be on because of hose beds, and you are arguably the subject matter experts on hose bed, and we got all engine. Oh no, we got one guy who's not an engine guy, but he is an engine guy, because if you were working for Captain Mike Dugan and you walked past on ladder 123 and you walk past a mess of hose or an engine company struggling, I know what Captain Dugan would have you do, and that would be to keep that line moving. So, and you know what? Tom Brennan was the same way. A consummate truck guy, but he understood what his place was. Dennis Laguerre, Ray McCormick, we've looked at various attack packages and patterns, and I've seen it all because I've been a firefighter for, it'll be 51 years. So I've operated with 65 gallon a minute nozzles, adjustable gallonage with 1.5 inches. And then in the Chicago area, you know, we're big on the use of 1.25 inch pipe. That's what that's Chicago jargon for a nozzle. But lately, you two fellas have been doing some research on a pattern that was used at one point and then has kind of went by the wayside. Can you tell us what you guys have been researching?
Go ahead, Dennis.
Well, you know, I've always been focused on Firestream development and application methodology, and the stuff that was just discussed earlier, the Kokoloff nozzle and the Brenston distributor nozzles. I'd like to point out that the Brenston distributor nozzle has a lot of ideal characteristics. It's large droplets. It's a broken stream. There's really 8 things you're looking to do: cover the walls, cover the ceiling, cover the floor, cover the fuel package, and get droplets in the gases as well. The Brenston distributor nozzle does that extremely well. The most researched fire suppression device in the world, I would say, is the water sprinkler head, which is a broken stream. Some people will call it a fog nozzle, and some people will call it a smoothbore nozzle. I would say that both of those statements are not entirely correct. The nozzleman or nozzle woman that works the pattern is essentially the deflector. The deflector's job is to give you coverage. The better deflector you are and the closer the seat you are and the larger the droplets are and the better the coverage is and the more simultaneous it is, the more complete extinguishment is. So straight and solid streams have the disadvantage of mainly cooling, disadvantage and advantage of mainly cooling from distance to near. So it's from distal to proximal, and it's relying on distribution. A sprinkler head creates a droplet fallout, but it's also cooling because the deflector is high and the droplets are falling through the thermal column. It is actually scrubbing heat on the way down as the droplets are going. So there was a fan pattern that was popular in the late 1800s. There was a lot of fan nozzles out there, produced a bladed stream, and it very much intrigued me. There was a gentleman who was working with Cal Fire to make a wildland bladed pattern, and the blade pattern obviously is going to have some reach limitations and stuff. And eventually they made a nozzle that can do both, which is when I became really interested. Then I started messing with the stream, and I immediately saw that it's like a Brenston distributor. It's a huge broken stream. There's big droplets going everywhere. You collect the fuel package nice. You get the walls, you get the fuel package, you get the ceiling, but it's unquantified. I need to quantify it. So I've been involved in some burns with it. And one of the things that I think Brent sent me some pictures of the original fan nozzles, and Bill, you and I have talked. One of the things that I think is exceptional about this pattern is that it does both. It does proximal to distal cooling as soon as the nozzle's open, and it also does distal to proximal. And I'm going to pull an old name out of the hat here. I just got off the phone with Rob in Zootech, who works at the NFPA now, and he's done a little bit of research. And this nozzle was very popular in the Northeast with several fire departments. And it was worth investigation. And I've been extraordinarily happy with the results. I kind of feel like they speak for themselves. Ray,
Dennis, let's
Yeah.
Let's,
So
we got a little video of a fire that I think was in Texas, and it shows the pattern being used.
So I'll do just a tiny bit of setup. Basically, there are 5 areas I was worried with: reach, advancing to an unvented compartment, growing a fire on the way to a compartment. Does the orientation of the blade have negatives? Is it vertical? Heat comes back to you. Is it horizontal? This is the one that created the most debate among my friends that are SMEs. Like, how far is this going to reach in heat? So I was like, let's not pull any punches. Let's flash 600 square feet. Let's get the nozzle on a long end. Let's see if the stream has at least 30, 35 feet of reach in it. Because any of these things for me were failure points that I didn't want to be involved anymore beyond this point. If it only had 10 feet in reach and heat, Bill, what good is it, right? So, like,
I hear you, brother.
Okay.
We're going to go ahead and show that video, Mark, from Texas.
The room has been lit.
So it's about 35 feet deep by 17 feet wide, the fire compartment. The approach is 50 feet deep, so the initial application is 50 feet, and the fuels are shielded. The couches are on the right and deep, so like we didn't. There's no reason to set up a burn when you're trying to quantify something, make it easy. This is a difficult fire to extinguish. This isn't the deep reach fire. I apologize.
this is just side by side fire.
Okay.
We would not be breaking those windows without having a hose line in place.
Okay, so Ray's correct. This is a 2-room fire, 1 vented, 1 unvented. One of the things that we had the benefit of, I'm not gonna. It's Dave Pruitt and Ian Bennett were major factors in making these fires what they were. All modern fuel packages, so these are not training fires.
And I think Kyle Romer is on the nozzle. Okay, we're going to move on, but our viewers can Google blade pattern. Is that correct, fellas?
That should get you to
Yeah,
examples.
that'll get you there. Okay, so if you want any further information on that, that's where you would be able to find it. Okay, Daryl, how's retired life treating you?
Well, so far, so good. And as we're in this discussion, one thing I'm thinking about is we just don't play with different water patterns enough. A lot of times we're just set on the world that we're in, and we need, we shouldn't be afraid to just try things. Obviously, Brent up there in Toronto, they try a lot of different stuff. I don't know how many people have tried a distributor nozzle on a master stream, or coring a hole in a floor or wall to get water to the fire. But at the end of the day, it's all about getting water on the fire. And one thing that you said at the top of the hour was turning that distributor head around so the water's going away from you, and that intrigued me, because one thing that I would like to try is a 1.5 inch distributor nozzle with that head turned around for fires up in attic spaces, but attaching that to the end of like a 6-foot pipe off of 1.75 inches.
That's
And
what,
is that
exactly
the way
what
yours is
Jacksonville
attached?
has. And I'll see, maybe next month. I'll see. I had trouble recovering that picture because it was on my phone and I couldn't get it on the internet because I'm computer ignorant, old man. I'm playing the old man's card. So, but that's exactly, Daryl, what they're doing. That's what they're doing. So, I think that we're thinking firemen. We've got to work smarter rather than harder. And I've always been intrigued by nozzle dynamics, hydrodynamics, dynamics of extinguishment. Bobby Halton, God rest his soul, man, was he passionate about fire screens. And you think that with all these well over 100 years of experience, we're still learning new things and relearning old things. So it's kind of interesting in that respect.
Well, at the end of the day, there's going to be some pros and cons of every type of water application method. That there's going to be some things that are going to be winners and some things are going to be losers, but we can't be afraid to try. I know Ray hasn't said this in this, but I remember years ago him showing me a brass smoothbore tip that he had kind of crushed to make a bladed pattern, because he was playing around with different water application methods way back then. And we know there have been other types of nozzles throughout the years, but yeah, get out there and try. And also, we tend to get passionate about the camps that we're in and somewhat, cult-like. And at times we need to just remain inquisitive and remember we're all trying to accomplish the same goal.
Yeah, and that gets it back down to Chief Riley's point. What works for you? Do you? What works for you? And for instance, my department uses key 2-inch combat ready. That works for us. Will it work for you? That's up for you to decide. At conferences, I had a guy tell me, wouldn't that be crappy if every instructor had the same tactics and techniques and strategy? No. So when you go to a conference, it's like a buffet line. You're going to pick and choose what works for you. I wish that Dan was here today, Chief Dan Shaw. This is the Fairfax County Fire Department, and what a great training video. It's just a garden apartment stretch, and it gives the pros and cons of taking a line up the stairs, charged and uncharged. Like on my department, on a standby job, hold it right there. On a standpipe job, we're going to, we're taking it up charge. That's what works for us. Because I don't want the line being charged underneath a door or in a stair railing. So that's what works for us. But this is garden apartment stretch, and they're going to show the pros and cons of both ways. Both are appropriate under the certain conditions. Okay, go ahead, Mark. I love that. Put her across your hips.
Yep.
Taking his working length with him. An improvised coil load. Well stretched. All right, that's great, and kudos to their training division, their video bureau, and that company that was being filmed. Just they operate so similar to what we do. Word of caution for firefighters in coastal areas. We have a lot of exterior hallway catwalks, if you will. Some companies will improvise and they'll raise a section of 3-inch with a Y in place of a standpipe, and that's fine. And then they secure it to the railing. Not a good idea when you've got salt air corrosion, especially a 3-inch. You're running the risk of that railing coming down and hurting somebody's feeling. Clark, fighting 38.
Yeah.
Clark.
Gentlemen, how we doing?
All right. Clark.
What I missed, bring me up to speed.
Huh?
What I missed, bring me up to speed.
No. We talked about nozzle patterns
Okay.
and specialty nozzles. And you came in at exactly the right time because we could go to your we're talking vertical stretches, and we've kind of shifted now to vertical stretches. So that's why I asked Chief Ricky Riley to be on, because we want to look at hosebed design that is conducive to these long, complicated stretches around corners and obstacles, up stair landings. So Clark or Mark, if you would you bring up that? Is it a video or just pictures?
Should be just pictures. Which one you're talking about, Cap? Yeah, that one.
Okay. All right. Now, what's the story behind this one?
So this is a 10-story residential we have in Vegas. You can see fire on the 10th floor in the corner. It was a wind-pushed fire that pushed into the hallway. The FDC was in the parking lot. So first company arrives, obvious fire through the window, makes entry, engineer stops, makes the hookups, starts pumping the standpipe. They set up on the 9th floor. company sets up on the 9th floor. They go to flush the standpipe, and they just get straight debris, just mud and rocks coming out of the standpipe. They immediately recognize that this is not your usual standpipe debris. We have a problem here. What ended up happening was the standpipe was broken in the ground. It was a very old, I don't know, very old, but it was a pretty old building. So at some point, that standpipe broke in the ground. So we have no water supply in the standpipe. The officer is on the 10th floor. Main commands, it was the senior fireman who was on the 9th floor, immediately recognized what was going on and called for the hose stretch, send the hose over the balcony. They forced into this apartment on the 9th floor and sent their hose off the balcony. Like you see, that's a 2.5-inch hose off the balcony. So in the meantime, the person pumping the fire, the engineer pumping the fire, he's in the parking lot. He has no idea anything's wrong until he sees the female coupling coming down the side of the building. And he immediately recognizes and he immediately knows what's going on. So that engineer grabs the crosslay, the 2.5-inch crosslay off the engine, and runs it all the way through the parking lot, disconnects the nozzle, and catches as that female coupling comes down to the parking lot. He catches it, makes that connection, goes back, and starts pumping that. They secured the hose on the railing because we don't have salt water here, Bill. So secured that hose on the railing, made the stretch, went up, and extinguished that fire. So
Okay, Clark, did they? I wasn't sure on this. Did they lower the hose down? They lowered the hose down.
they lowered the hose down because they already had their standpipe packs, the high-rise packs already built in the hallway in preparation to take it to the floor above. So they just took that female coupling and sent it right off the balcony.
Yeah, and I get this question quite a bit. What's the maximum vertical stretch? And I know Dennis Laguerre and I have discussed this. I know that you've gone off the roof of a 25-story building.
Yes.
And we discovered the first time we did this off the roof of a 16-story building that the pinch point was the parapet or the windowsill. Parapet or the windowsill because of the weight of the vertical stretch. So the key as in key hose, the key was to support the uppermost suspended coupling so that the weight of the entire stretch vertically suspended is being assumed by your rope and your tubular webbing. Whereas and it also allows the hose to form a nice gentle arc or radius over the parapet or the windowsill. So let's show that next picture. Okay.
And the one point that I want to make on this, Bill, is this happened. It wasn't the officer that made this call. It was the senior fireman that made this call. He immediately recognized we had standpipe failure, and he initiated the vertical stretch. And then it was the engineer in the parking lot who saw the hose coming off the building, and he immediately recognized what was going on. And does anyone here think that this is the first time this operation happened? Absolutely not. This company has been training on vertical stretches. It was Station 18. This company has been training on vertical stretches, this exact stretch, because we realize that these standpipe buildings are unreliable. And so they've been training on this. And everyone on this panel always says you have to have a plan B, a plan C, a plan D, right? And it's not that plan B can't be. Remember when we listened to that lecture at FDIC like 7 years ago? What were those guys talking about? Absolutely not. As we are ascending into a high-rise building or a mid-rise building, I am already looking at the stairwell. I'm looking at the stairs. I'm looking at access points. Are we going to go the well stretch? Are we going to go stairwell stretch? Can we go off of a balcony? I'm immediately formulating plan B, plan C, and plan D as we are ascending. I'm expecting standpipe failure. And that's why this company was so successful. We confined it, slight damage to the hallway, but confined it to the apartment of origin on this fire.
I know this is about engine operations, but when I'm looking at this photo, I can't help but to think of this Chicago firefighter that recently passed away falling down a light well. The roof had no parapets. And if you look at this building, there's no parapets there. If
Right.
you can't see your feet on a roof, you need to think about, getting down on all fours, because that would be a pretty long fall.
Yeah.
Yeah, excellent point, Daryl. Excellent point. Yeah, and our hearts and prayers go out to that young firefighter that fell down that light shaft. It was just tragic. Clark, you have another picture here for us?
Yeah, I think we do. That's the same
Yeah.
same building. Same building. You can see the hose. You could barely see how they secured it. They actually secured it on the nylon, which I'm not a fan of, but it was only a 9-story stretch, so it did not occlude the flow.
Right.
Right. Anything higher, once you start getting into the teens and stuff like that, I always try to capture the brass, because there's just too much weight on that rope, and I think you're going to start occluding the flow by pinching that hose
Bingo.
off.
Absolutely, totally in agreement.
Oh yeah, that's unrelated topic. That is brand new engine 18. We have it's not actually ours. It's Rosenbauer is letting us borrow an all electric fire engine right there, and they're trying to get us to buy it for the cool price of $2 million. They even wrapped it for us and put our logos on it, but we don't own it yet. So they're loaning it to us for a few months to see if we like it. So, all right. This is another alternative stretch that you were talking about, securing the last coupling. Now, as far as you mentioned, how much hose can we suspend? Well, this is a training we do, and this is a static display. This is a 18-story high rise. And in the morning, we charge this 2.5 and secure it in this configuration. This is key hose. And we secure it in this configuration, and we let it hang like that for 8 hours as a static display. As the students come by and they take a look at it, we talk about securing hose. We've never had a hose failure. 8 hours in that configuration at 17 stories, and that last stick of hose goes up to the 18th story with a Y on the end of it, where we connect our attack lines. We've never had a hose failure doing this training, and I have never heard of any hose failure. And if anyone has, I want to hear about it, because I'm always talking about this is a completely safe way to secure hose, and this is an option. The hose manufacturers typically don't come out and give us a number, but I don't know of anyone ever having any kind of a hose failure with the nylon separating from the coupling. So this is a great example. 8 hours with that much weight and never had a failure.
Dennis Laguerre, we've had this discussion, and I do believe you've done the calculations or actually have done the tests. And now we're talking high-end, high-quality hose. This happens to be Key Combat Ready 2.5. Yeah, I'm endorsing Key hose. I like Key hose, and it's never failed us. Dennis, any figures that you have, and how did you arrive at these figures? Are you there, Dennis? You're muted again.
I just looked up the email we had 9 years ago when I started messing with this for clients, and it's UL 236 is the standard. And in an expansion ring coupling, you get 1 ton of pull-out strength per inch of diameter of hose. And kind of strange, it happens to be section 343. That's just the way the cookie crumbled. On that one, we often see that number pull up. So it's 343 of UL 236. But essentially, that means you can go to 450 feet or 1,188 pounds, and that still gives you the 4-to-1 overhead safety. So that would comply to overhead lifts at a work site for OSHA. So I've done 30 stories. New York's ultra high rise team has taken the cake. They've done in a elevator shaft. I can't remember, but it was like 60 or 70 stories. It was a lot.
Dennis, was that suspended by 1 coupling?
That I'm not exactly sure, but the weight's not the issue. They used triple duty hose. You start running into a pressure issue At 450 feet, you would need, roughly 195 pounds of just head pressure. Then you need the pressure for your attack system. So when New York did it, they actually used their high-rise, high-pressure hose so they could actually get the pressure that is required. Buy a very good hose. I always say it has to be UL 236 compliant or better, no matter what manufacturer's delivering it. Expansion ring, you got to take care of it, maintain it. But typically your problem's going to be the way you hang it. It's not going to be a single coupling failure, and it's going to be, the vast majority of the American Fire Service deals with buildings that are 30 feet and under. One thing that I think Clark didn't point out, but it's definitely true, coupling drops are way more easy than hauling hose up. Hose get heavy. If you're at 10 stories, that's let's see, good quality 2.5, in my opinion, is 30 pounds coupled per 50 feet. So that's going to be 60 pounds. That's a lot of rows on the rowing machine for a guy, even if you have a 100-foot rope. So it's easier to bring the hose in the building and drop it.
If you have a high windowsill, it's all upper body strength. You have no leg muscles that you can use to pull the hose with your legs. And yes,
Ray has a tool that he loves.
The
hose roller. Brent, do you carry a hose roller on your high rise?
We carry
Jimmy,
2 of them, yeah.
Engine 43. Are you muted, Jimmy?
Unmuted now, Cap.
All right, Jimmy.
Welcome back.
You're at Fighting 43. Early in the 70s, I realize you're on duty, man, and that's got to come first.
Yeah, Cap, can you hear me?
Yeah.
Okay, yeah, I missed it all. I couldn't hear you.
Okay, can you hear me now?
Yeah.
Okay.
The Verizon commercial. I can hear you. Can you hear me now?
Yeah, I've got a 1950s vintage Chicago Fire Department drill manual that does an excellent examination of hose rollers, and for primarily point of vantage. Point of vantage. Is everybody familiar with that term? I think it's a Chicago term. Point of vantage, where they will get up on another building, and direct the stream from the other building into the fire building to protect exposures and take the place of an aerial ladder. And I believe, Jimmy, that they secured that hose to the windowsill or the parapet with a wall hook. Big.
Yeah, Cap. They use the old wall hook, depending on how far the point of its patch, the attachment, and then you would do the old school knot tying, the chimney hitch with the sheep shank. How's that one for dating myself, huh? Chimney hitch and the sheep shank.
You know that I had a guy.
We would secure.
I had a guy call me up and say, "Hey, Cap, what's the best way to bring a hose line up to the 5th floor?" Well, the fastest way is to drop a rope. You can either lower or you can drop a rope. And he says, "Rope? Oh, no. The only unit that has any rope on it is our technical rescue unit." I was appalled. Hey, you're a professional firefighter, whether you're career or volunteer. For God's sake, you better know how to tie knots. Okay? It is a basic fundamental skill.
Mm-hmm.
A basic fundamental skill. Have you had any fires today, Jimmy? You're muted again. Jimmy,
No,
can you hear
nothing
me?
yet, but it's still early.
Okay. Yeah, the day's still young.
Yeah,
All
I
right.
can hear you. Yeah, nothing yet, Kip, but day's still early.
All right. I want to spend the majority of the time that we have left, and we don't have a hard and fast stop, but I met Chief Riley when he asked me to teach some classes for Clearwater. And at the time, he had brought what he had learned from Prince George's County. And you were on Kentland at one time, too, weren't you, Chief? Okay, you were on Kentland. 33, right? 33. And so he brought a lot to the table because there's quite a cultural difference between Clearwater, Florida, and Prince George's County or Fairfax. And I was very impressed with their hosebed configuration in the design of their apparatus. And at the time in the state of Florida, I don't think there was anyone that had a low hosebed like that. So if you were to recommend a hosebed in terms of width, height for an apparatus that would enable firefighters to shoulder hose or put it on their forearms so they could go up stairs, ramp stairs, or around multiple obstacles like parked cars. Can you give us some recommendations, Chief Riley?
Well, the low hose bed is certainly nothing that's new. I mean, the FDMY has been doing it for decades, if not more than decades, centuries or whatever. So, they have that down pat, and that's because their apparatus designed to get the hose off the rear, and they're using a square tank as opposed to most of us that are using, L-shaped tanks or T-tanks that drive that hose bed height up. So once again, we just got to figure out, how low we want it, and then how deep we want it, because as the hose beds get lower, depending on your wheelbase of your fire apparatus or how much water you're carrying or how much compartment space you need, that's can shorten your hose bed up. And then if your hose bed is short, that's going to drive the height of the top of the packed hose up high, and then you've kind of defeated the purpose. So, it's 50 inches or lower is a great one. Just for the ergonomics of the firefighters today. We're all different sizes, and we're all wearing PPE, and we want to prevent injuries. So that's kind of important. And how we rack it is critical. But it all that depends on your staffing. I mean, New York City can make the stretches that they make with their great staffing, and then the design of their apparatus. By just grabbing a couple loops, everybody grabs a couple loops, and off they go, and off to the races. Whereas with limited staffing fire departments, we have to make a combination of low hose beds, Minuteman loads, any kind of special load that you can get to help your fire department get to where they need to be. And of course, like I think we were saying earlier, it has to be practiced. I mean, there's, just to copy the New York City hose bed and expect it to work in any town USA is not going to work. So, you have to make a few, and that's what we did. I mean, when as in Florida, they had that tragic fire in their, in the early 2000s. And, they had a lot of high-rise issues. And, we talked to Dave McGrail, came down and gave a fabulous class, on high-rise stuff. And we were using the FDMY, high-rise packs. And that worked great with FDMY staffing. Works flawlessly for them. But it doesn't work great with a 3-person engine company. And, you're leaving one person down at the pump panel. So, that's when, I met you, and we talked about 2-inch hose. And, that's when the department switched to 2-inch to try to help reduce the weight, and then also try to give us some kind of flow up there with our limited staffing. So,
yeah. And then you got your company went out and we did it on an exterior stairwell, so we could take pictures, and I was very impressed with that. And yes, you're correct. The low hose bed was not new, but it was new to the state of Florida. Some of the things that you brought, that's the advantage of looking beyond your boundaries. There are some firefighters that are not interested, or they think that they're on the best department in the world and they don't need to see what other departments are doing. Greg Redmond, we carry a hose roller. I still prefer a hose drop. You're right, brother. We do. And the more you get out and take a look at other departments and see how they operate. Let me give you a loaded question there, Chief Riley. What do you think of this triple layer load?
I'm going to remain silent because I don't know everybody's opinion on this panel. Yeah. But I just don't see the advantage in it. But there are places I know in Pennsylvania that just swear by it.
Chief, that was a loaded question. I am so proud of my department. I think we're the 6th biggest in the country, and our bosses are firemen. They're firefighting guys that went up through the ranks, and they listened and they watched. And the fact is that we adopted the triple layer in 1979. Our opportunities for stretching directly at right angles from a cross lay and going to a front door in Miami-Dade County have diminished drastically over the years because so many of the houses are divided up. We got parallel parked cars, and you know that the hose and tires against the pavement is a hose magnet. You know you're gonna hang up. So we're stretching more to the Charlie side than we ever had, and we're going to continue to do that. Now the wind today is 40 miles an hour here in Miami, and the weather's crappy. It's rainy, but you got a 40-mile-an-hour wind, and it's primarily coming out of the north. You better really think about when you're doing your 360, if you have a perceptible breeze blowing in your face, man, you better think twice, because if those guys come in the front door and God forbid they're on the leeward side and God forbid the windows fail they're on the leeward side. If they fail on the windward side, they're toast. They're toast. And I think we know that there's been dozens and dozens of, and it doesn't have to be a high rise, and it doesn't have to be a very strong wind. I think back to the two firefighters in Houston, Texas, in a big ranch-style house. And it was, everybody should be aware of that. They should go to that NIOSH report and take a look at that, how conditions so quickly changed on these guys. Because in my estimation, and I don't have the report in front of me, when they entered, on the leeward side, there was a bidirectional flow. That was the only opening in that big house. So below the neutral plane was an intake. Above the neutral plane was an exhaust. But it all changed when the sliding glass doors failed, and then their faces were directly in the flow path, directly in the exhaust of a unidirectional flow coming from the rear to the front of that house. So I recommend that we should all be studying NIOSH reports. And you know, it raises the question, is it fair to second guess firefighters that have made mistakes? And yes, it's fair. It's our responsibility to our families and to our departments, to the guys and girls you work with, so that we don't repeat the same tragedies. And that's why all of us in this group right here are huge students of the fire service. Jimmy, do you have anything to add to that as far as you have? If you could tell us a little bit about your response still district, in terms of the challenges that you have in your multiple dwellings.
Yeah, Cap, everything's a walk up over here, 3 to 4 story ordinaries, and then the introduction of the newer contemporary mid-rises. 5, 6, 7 stories, just under code for the standpipe allowance. So in Chicago, it's 79 feet. Anything bigger or taller than 79 feet, you've got to have a standpipe. So we're finding these buildings, they're under 79 feet, and you need to be very creative of how you're going to get that. You're going to get that attack line up there. And you got to stay sharp on all the methods in doing so too, Cap. You know, the windows are a popular drop for us, or the well. I mean, those are going to be our two go-to, but it's important to maintain your bearing and knowing where you are so you can go to the street side if you're going to do a coupling drop, and make sure you're on the right side so that your engineer can see you. And sometimes very difficult to get lost in these buildings too, Cap, but they are so wide. All right. And then I was in one today, 250-foot stretch if you came up the wrong stairwell, 250 on a contemporary mid-rise sprinkled building. So yeah, that can really throw the curveball at you. You know, and I like to say, you got to know your buildings. You got to get in these buildings and know what these stretches are. Look at your options. Pick a couple options and practice the hell out of them.
All right, guys, we're coming up on the hours here. Does anybody, any final thoughts, comments? Brent, anything from you?
Yeah, if Mark pulls up that picture, we're using that straight pipe with the Bresnan that you guys were talking about, and maybe it's the next slide. But also, there's manufacturers out there that you don't have to reverse that Bresnan. It actually comes already like that. So depending on which Bresnan, that's why there's a number of different ones. But we'll use it for garbage chutes because we're actually sending water to come back down. But that's our straight pipe. You can see it there in the top of the picture. Our opposing tip, our rotary distributors, and everything works off the same in hose and nozzle package. So when we call for a tactics change or we're going to get hidden voids, we simply add to the front. The line's already down. There's no point in stretching another line. We switch tactics at the front. But yeah, the Bresnan distributor, that could be a whole episode on rotary distributors.
Right, and like I say, I knew that we would just scratch the surface, but it gets us to look forward to next month. This is the kind of meat and potato type stuff that we never get tired of talking about. And learning from each other. So I want to give a shout out to Key again. Yes, we use Key hose. I believe you use Key hose, Clark. You hear me?
We are not in Key hose, Cap. If I was on the purchasing committee, we would be in Key hose, but we are not.
Okay.
So.
But at conferences, you've used the Key hose.
Absolutely, yes.
Yeah. So, and also the FDNY version of the Key, which I understand has a more robust jacket than the regular Combat Ready, is something that intrigues me. And but don't go cheap on hose. Thank you, Key. And I want to give a shout out to Mark Lighthill and Dave Hibben. Dave, I will see you, DC Engine 10. I will see you next month. And for our special guests today, that would be Chief Riley and Dennis Laguerre and Ray McCormick. And where are you going to be? What department store are you going to be the Santa in this year, Ray? You're muted, but I think we got an idea of what you said. Hey, guys.
Hey, Cap.
Yeah.
Real quick, if you want to nod to history for a second around stream placement and Brent's last slide up, you saw the Blitz fire there, the mini monitor. I kind of like to give credit where credit's due. I think basically Paul Shapiro invented, the single inlet.
Absolutely. God rest his soul. He came to me with a big nozzle at FDIC years ago. And I think he called it the Big Paulie. And yes, I do believe that these portable master streams, that is the ones with a single inlet, are the brainchild. If anybody is responsible, it is Paul Shapiro. God rest his soul.
When I teach, I just call them, give me the big Paulie. I don't reference manufacturers. So here's fire engineering principle and practices of fire suppression. If you look in here on page 367, there's the ladder evolution for the floor below nozzle. That was a Lieutenant Lorenzo, the first floor below nozzle here. You take up another good history here lesson. We got Fire Stream Management Handbook. We got Fornell, right? The bent tip from Ohio, Bauer, Mr. Bauer, right? Placement means something. You take Vincent Dunn's book, right? Vincent Dunn's book. You get in here. Bredsden, the chief from New York, right? Right? Different bent pipes, specialty nozzles and patterns have always been a thing in the fire service. Property is 9/10 of possession is property. Having it 9/10 of extinguishment is placement. And Brett, you're doing wonderful work in those regards.
I want to give a shout out to Dave Cornell. I met him in the early 70s in the Chicago area. And yes, his book was, he shared information with me, and I still consider him one of our foremost authorities on fire streams and hose placement. I think he's still with Detroit. And there you go.
Must reads.
All right, my brothers. I hope you all have a very Merry Christmas. Very Merry Christmas. Or Hanukkah. You got to run, Jim? Okay. So until next month, we'll continue this discussion. Thank you, participants. God bless you. And for everybody out there, may God keep you safe on our most noble of professions. See you next month.
See you guys.